computer. Okay, today we are jumping to Gaddis chapter 16. And then we're going to hit Nye off a little bit for the second part of the class. But this first part, we're going to talk about something that are called exceptions. And you will also talk about exceptions in CPS 230. Now, you've seen this word exception a long time ago. Back in CPS 121, when you were working with files, you saw this word. What was it part of? It's part of the statement throws IO exception. That goes all the way back to CPS 121. Okay. So these exceptions are what happens if while I'm running the program and it crashes. Okay. An exception ends up being an object that's created, as you saw in CPS 230, of, hey, we got a problem. How do I handle it? Some of you had, like I said, 230, you have try blocks and on and on and on. But by definition, it's used to signal an error or something that just goes bad, like I said, when you're running your program. For example, you say to the user, please input a numerator, 11. Please input a denominator, 0. Your result is numerator divided by denominator blows up. We're not allowed to divide by 0, as you know by now. So that's something that you could catch with an if statement, but if you didn't, it crashes your program and an exception would occur. You have a file. You're reading in int. Hi, mom, int. Whoa, it's going to crash when it got to hi, mom, because it wasn't an int. Okay, that a mismatch. So when an error occurs, we start to get into some lingo. We start to see the word throws and thrown. There's two of them. But an exception is thrown. That means this error goes somewhere. Some class will take it and say, here's what I want you to do with it. We don't always need to have it go to that class. We can write our own exception handlers. We want to handle an exception. How do we do it? We put it in what we call a try-catch block or a try-catch construct. So I'm going to grab the book. I'm going to go to Gaddis chapter 16, not 19. We jump around in the Gaddis book, but I think the way we flow is the right way to do it. And people tell me I'm wrong all the time. Okay, so let's look. Comments I just made, and I gave you the classic example. It's this denominator equals 0. If I use an if statement, great, I caught it. It's not going to divide. But if I didn't, something bad's going to happen. Lots of different things bad going to happen. Now, 16.1. Here's what we can do if an error occurs. Lots of different types of errors. All right, let's see. We come in and we do this, and we may accidentally try to divide by 0. So this is looking for that type of error. In this block of code, a try block, if an error is converted or caught, it gets thrown to this catch statement. Okay. This one just simply outputs that message, whatever's stored in exception string. So if we come over here and we're writing our own. We're writing our own. If I come in here and all of a sudden the denominator is 0, I create a message and I throw it, which means over in the catch, it's going to catch this exception string. 230 treats it a little differently. But here in 162, we're going to start out with a simple one of I'm throwing my own. This is a user-defined one. There's lots and lots of stuff we could do with try and catch blocks. The best way to do the rest of this, I think, is with you with hands-on. Go to D2L, download the zip file with chapter 16 code listings in it. And I want you to grab the first one. It's rectangle.h version 1. Do, 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 do. Do, 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 do. All right. Specification file. You need 30 seconds?
Oh, where's the file at?
Should be on D2L, chapter 16. Files for today, chapter 16. It's a zip file. Top of the news.
I found it. Thank you.
Okay. So you hold on a minute, hang on. Anybody not there? Give me a hold up. Okay. Version 1, the specification file. I come in and what is going on in line 13? I have a class rectangle. I have two fields, length and width. And then I have including a class. This class is empty. Step 1, version 1. I also, after that class, that empty class, I have my normal constructor. Name of the class is rectangle. The constructor is rectangle. I have set width, set length. They're not there. Mutators. I have a couple of accessors. These are inline. They're written here. We didn't need to write them over in our implementation file. In the implementation file, I go to the two functions that I had to write. Notice the name of the class, the SRO operator, the name of the function. Throws a negative size, throws a negative size. Where was negative size again? It was over here. There's nothing in it right now. Okay, we're building. This is in here. So if a width or length of less than 0, it's going to throw it and catch it. Now, what's going to happen here? I come in my try block and I do the set width and set length. And if an error occurs, we know we're throwing that negative size, which is going to come in here and simply print out a negative value was entered. So we're trying to coordinate all of this right now. Come in the try block. The try block goes over to the implementation file. If there's an error, it goes to the negative size class. Negative size class doesn't do anything right now except send me to here. And I print out a message. Now, slowly, we're going to do things inside of that negative size class, which means, so what happens now is if it does this and it goes and it prints out this message, I now move on to line 32. I had an exception occur. I handle it, and now I can continue with my program. Shooby dooby doo, end of program. All of that was going on and so forth. All right, go load up version 2. And we're going to see this time where we have multiple, where are we at? Here we go. Multiple exception classes. I'm back in my spec file. Let you load it up. I'm back in my spec file. Something from my implementation file can throw it here. Something can throw it here. And again, I'm not really doing anything yet inside of these. My demo, I come in my try. If I set width and it's bad, right, it goes from here over to my implementation file. My implementation file says, hey, there's an error. Throw it to negative width class that's in my specification file. Nothing's really going on. So then it just comes down here to this catch block and says, what's going on in that negative width file? Well, not much of anything, but I'm just creating a message for now. Same with rectangle. So I can have multiple exception classes. And those two classes were listed inside, again, they're listed inside my spec file. Nothing's in them right now. These are kind of like inner classes. Please tell me there is another one. Let's see, 16.4. Remember the days when you used to have to type all these in? Try block, a catch. We know this is all. I like this. This is good. I catch it and say, please enter a non-negative value here. So I get width. It's going to go back up and run it again until something good comes in. Then I get to, so this block right here is kind of nice. We did this with while loops, input validation. But here's another way to look at it. This is baby steps to what we can do with the power of this down the road. I get a rectangle's width. I come in and I check the width. If it's good, try again becomes false. I skip the catch. I come, oh, and I'm out. I get into here. Otherwise, I stay in here. If I get a message, it throws it to here. This is just a little addition to version 2. We're not into version 3 yet. I like it. It's a way of catching bad data. You're starting to get into, with more and more stuff we add in here. I said to my wife one time, she walks up and says, what are you doing? I said, well, what's it look like? She said, hieroglyphics. This is a foreign language to people. Who? All right, go load up version 3. Let's see what's going on. I'm back at my spec file. I know what has been in it. And up until this point, this exception class for negative width and the one for negative length were empty. Now I have something going on. What the heck's going on? It comes in here, and I have a constructor, same name as my class. So a value is coming in with this constructor. I have a function called get value. So that means over in my catch, I can use this function get value. I could use any function that I type up inside of this class. I'm so excited. I just can't hide it. Okay, let's see what's going on. I come in, I get a length and a width in my demo program. I come over and oh my this is a try block. The try is on the previous page. This is a try block. I come in and set width, I set length, I have the area, and done. Uh-oh. What if there was a bad width? So over in my width, over here, I throw negative width and I send the value in. So all I need is the class name, and this time I send a parameter because I had a constructor to go with that parameter. What happens once I catch it? I come in the catch and I go to print out a message and oh, look at this. This guy right here is an object. When I catch the rectangle, when I catch the negative width, this time I'm catching an object. I'm going to use that object so I can get the function that was in negative width. Damn. You notice the try, there's only one try, that's here and that's here. And we have something set up to catch both of these. Now, what I would normally do is give you this assignment because we have a function here set width, we have a function set length, we have a function get area. Well, what if the area ends up being too big for the job? And I'd like to have something set up where I would catch a um, extra large get, my area is too big. So now, normally, like I said, if we had two class, we would go and do, well, let's see, we'd need a catch block. So over here, I'm going to do a catch block because again, this is going to be part of my try, just like set width and set length. I need a catch block that says catch, staying with rectangle, colon, and I would need a name for the inner class. Give me a name for the inner class. Make something up. Good. Let's call it bad area. Bad area. And I'm going to write it where it's bringing an exception in. So bad area E. Okay, this would be a third catch statement. I'm catching bad area. So it's going to be a lot like these braces. Some kind of message inside of here. All right. So this would be in my demo. I would add that. Where else do I need to add something? I would need to add something in my implementation for get area. So in my implementation file, I would need something that looks similar to this. Void, rectangle, because it's my rectangle class. Get area. Okay. There was a get area way over here, but we would have to change this. So we would have to fix this in my specification file. We would need to add another class bed area, and write all of the following to go with it. We just sort of did it algorithmically. So I would need something that looks like, let's see, class. Y'all are watching, you're going to tell me when I mess up. Bed area. Okay. And what do we have going on in here? We have private. We're working with the value again. That's fine. Public. I'm thinking we're going to need a constructor. Constructor would be bed area. And what is that bed area? We're going to store it in val as it comes in. It's stored in val. And then I'm going to assign it to value, because once I assign it to value, then I can use it in whatever kind of message I would be using below. So I'm going to return a double, and it's going to be so the class is called bed area. Get area. I don't want to screw anything up while I'm here, but I would return the value again. So that's my class. I created one. I'm bringing in a value. I bring it in with a constructor and store it as my identifier value. And then if they want to know what it is, they can get it. Which means, and it's similar to what these other two were. And then finally, over here, I would need to now, instead of having it inline in the specification file, I now need to make it over here in my implementation file. Void rectangle, get area, yada, 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 yada. Okay? Not the best way to do it, but hopefully if you, I think I explained it okay. So if you needed to rewatch the video, you always have that. Part two, part two today, something called function templates. Going back to handling exceptions, we spend a lot more time in CPS 230 doing it. We just worked on user defined. Over there, there's a lot. We spend a lot of time on exceptions. It's a good introduction now. Next thing up, templates. Templates. Where's my yellow marker? Don't know why this isn't highlighted. Say I write a function, and these are function templates. There is entire class templates. But what if I want to create a simple function template? This is like two miscellaneous things stuck in this chapter. Want to create a function template. Oh boy. What if I had a function called square? Okay, square. And I want to take an integer and I want to square it. And it returns an integer. Okay. That's good. But what if I want it for doubles as well? What if I wanted it for another numeric data type? I'd have to keep writing these same things over and over. No, I don't have to. Instead, I can use something called a template. A template looks exactly like this. Instead of int, I'm going to put a T. And I need to let the program know it's a template. So I have this first line, template class P. So now if I called square and passed in an int, it would return an int. If I passed in a short, it would return a short. We're able to use this thing called a template. Kind of cool. Kind of cool. Program 16.7. You have it. You don't need to load it up, but you have all this stuff now. The syntax. I need that extra line. I replace the data types. I need that extra line. I replace the data types. I need that. This is a test question. That's why I'm saying it 3 times. It's like Beetlejuice, clicking my ruby red slippers together 3 times. I need that extra line to say it's a template. The keys all match up. All right. That's easy. I'm jiggy with it. Oh, here's a template. Nice. You've done this several times in your programming career up to this point. What if I wanted to do a swap? I want to swap 2 variables. Line 6, they're being passed in as reference variables. So when they return, they get to new values. Once again, the address is being passed in. Here's a T, here's a T, here's a T. And I swap them. Would work for ints, for doubles, any data type you can think of. Anybody think that's cool? Can I get a thumbs up? Okay, I got one. Down here in the output, you notice, oh, this was working for chars. It worked for integers. It worked for doubles. I didn't even mention chars a minute ago. You mean there's more? Of course there's more. What's going on in this block of code? I've talked too much. What do you think's going on here? I come into the main, I have an int, a char, a float, a double. I come down here and I pass in an int and I pass in a double. So int goes into this first guy. Oh, he's T1. Double goes into T2. Here's T1, an int, here's a double. This comes in and compares which one has the larger size. So when I come down here and I call largest, first one's an int, the second one's a double, which one uses the most memory? The largest of the two is 8 bytes. That's the double. I'm comparing a char and a float. I send it in. C becomes T1, which is a character. T2 becomes a float, gets the size, returns one of them, the size of one of them. Comparing a char and a float, the largest of the two is 4 bytes. what's going on over here? Oh, what's going on over here? I have T and T. I am, this is some, and this is some. What's the magic word?
Overloaded.
Overloaded. Yeah. Same name, different parameter list. Same name, different. Exception. What we're doing today is not on the test on Wednesday. Just a reminder. Yeah, I can overload templates. Cool. I'm jiggy with all that. Shoo-doo-doo-doo-doo. Shoo-doo-doo-doo-doo. Doo-doo-doo-doo-doo. Doo-doo-doo-doo-doo. And you come to the end of the book. Last class, somebody said, well, we'd like more programs to work on. Here's one that I would recommend you do if you wanted to practice templates. Just write your own, not real hard, but practice it. Not for this test on Wednesday, but for the next test. Can you pull it off? Can you write it? How would you check it? Well, I'm pretty sure all the solutions are on your D2L page. Not positive, but I think I have them all on there. A nice, simple practice. Questions? Okay. Templates, exceptions, not too bad. The next on our list is what's called a doubly linked list. And there's a little bit in Gaddis, but there's a lot of good stuff that's in the NIOF book instead. And we come into what does a doubly linked list look like? Well, we got something like this, and they go through and do the drawing and so forth, but we get a doubly linked, and they make it vertical. Well, I kind of like it horizontal. So as I draw this, you decide which you like, vertical or horizontal. But we are going to start with, first of all, constructing, what do I need inside of my node? Well, it looks like I have two pointers this time. One pointer's going to the next, one pointer's going to the previous. So I'm going to grab a piece of paper that's not already all written on, and I'm going to start with how would I draw? All right. So we're going to come in and I'm looking at, I need data, I need a prev for previous, and I need a next to go to the next one. It's going to look something like this. 6. It's going to have a pointer that goes there. It's going to have a pointer that goes there. So lots of stuff going on. And if I can go forward and backwards, I should probably know where the beginning is. Instead of head, we'll call this first, and where the last is. Because I may want to get to the end of my doubly linked list and go backwards. Something that I couldn't do before. Couldn't do it before. But now I can go last, and just like I used next, I'm going to be able to use prev. So I might set up something that looks like this. Couple of nodes in here, 5, and I'm going to go to 8, and eight's going to go to 12. And again, it's up to you if you want to lay them out like I am, horizontally or vertically. Totally up to you. And another one called maybe 15. And my prevs need to point back. All right. So some things to talk about this bad boy. We just said we're going to have a first. First is going to point to that first one. We're going to have a pointer called last. It's going to point to that one. Okay. Some things to talk about. Oh, this guy has to go somewhere. This guy has to go somewhere. Where would the logical choices be?
Point to null.
Yeah, yeah, we can go to null. We can go to null. We're good with that. Now, there could be a reason why you're using this layout and last next, watch this, last next would point to the same place first points to. First Prev could point to the same place last points to. But hopefully we got pretty good. And if I said this first, next, next, Prevs, Prevs, value, what would it be?
Wouldn't it be 8?
It would be 8. First, next, that's this guy right here. Next, that guy's next. Remember, address, 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 address. And then it would get me back to that value. So this would be the prev that goes with it. Good. Good. We're starting to get better with this. Starting to get better. All right. What are my two big functions? What are my two big functions? We've seen them in everything. In fact, in queues and stacks, they even had unique names. We had
Pop and
push and
insert,
pop.
or InQ or XQ? Or
Yeah,
DQ?
push and pop, NQ and DQ. We had those values. Okay. Where did they come from? Well, they came from originally with a list, and this is really a lot like a list. Insert and delete. All right. So we know we would have to write those functions. First things first, test data. I wanted to insert. Tell me what I would have to do for insert. What would be the first thing for insert? See if I can get this habit coming through. First thing for insert is
Create a new node.
it empty. No, no, no. I'm saying we're doing test value right now. Not you're writing the whole function itself. But for right now, I need me to look at this and go, first of all, is it empty? How would I handle that? Give me some numbers to insert. Like if I was going to insert a new node, what number would I insert? First one might be
3,
3. Give me another one.
10,
10. One more.
20.
20. Excellent. Excellent. Is it empty? What happens if I put it at the very beginning? What happens if it's in the middle? What happens if it's that last one? Yeah, boy. Give me some numbers for delete. I have to check to
5,
see.
12, and 13.
Well, first of all, I'm going to say is empty again. Want to get in there and start screwing around, it's already empty. First number was Somebody ripped some off. What'd you tell me?
5,
Yeah,
12, and then 15.
12, 15. Good start. What about this number? 3. It's before the first number. What about this number? 7. Because I go to 5 and then somehow I get to 8 and I want to stop and say number's not there. Oh, 7. 12. That's a good one. 15. That's a good one. Give me one more.
13.
How about 17? Like this, the 7 takes care of between. So this is before. This is the first item. This is the middle. This is just a middle item. This is the last item. And this is after the last. So when I'm writing my algorithm to do this, I'm going, hey, I got to keep all of this test data in mind. Got to keep all the test data in mind. All right. I am good. I wrote on that. I'm going to keep my linked list there. And let's just do this. I want you to add a node. I want you to add. So we're just going to write in that, and this is all I can practice. We're going to write to insert 6. So not that 6. We have a new node. New node. We just created it. It's called 6. I mean, its value is 6, and it's called new node. And I want to insert it. Let's see if we can come up with an algorithm.
Wouldn't you check to see if the new node is less than the first? And if it is, then you would insert it there.
And
Well, you
so,
would
all
look
right,
for if it's
so
empty
let's
first.
let's start with this. I need to traverse through, and when I do that, I know I need a temp pointer. Good. Create new node. Good. So my function passes a value in. I get a temp pointer. I do that. I may even say, yeah, let's let temp pointer equal what value?
Yeah, first.
The first. Yeah, temp pointer equals first. Okay. Let's see what we got. Do, 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 do. So this, all we're doing is inserting in the middle. And we know there's a lot of different locations to insert. So this might get pretty long. Like, let's go ahead. Let's see if we can come up with some stuff here.
If empty, then first equals new node, else while um,
If
the next equals.
wait, what did we do? If not first. So if there's something there, this is true. If there's nothing there, this is false. First gets a value of,
Of new node.
yep, is that it?
I think so.
Something we're not used to. How about last gets the value of new node? Yeah. Hmm. Else. So far, so good? Good. Else I need to traverse through. And we're gonna get there quick. We're gonna say this, else if temp pointers value is less than new node's value, and so when I want to put the 6 in, it's got to be greater than 5 and less than 8. Got to be greater than 5, less than 8. So this really is a separate block. If temp pointer's value is less than new node value, excuse me, that shouldn't be less than, should it? No, temp pointer's value, right now temp pointer's pointing to the first one. If its value is less than new nodes, so right now, temp pointer's pointing to the first one. Here's temp pointer. It's just at this location. It's pointing there. If temp pointer's value is less than new node and and new node's value is less than
Temp PR's next value?
is less than temp pointers, well, temp pointers next. Temp pointers here, its next goes over to there, its value. Oh. So it's between the two. The current value is less than new node's value, and new node's value is less than the next one. Then what do? I got some good stuff going on here, and this is what we're after right now. I need to get this 6 in here. What you got?
Just a suggestion, but wouldn't you want to set the temp PR's next previous to your new arrays?
Somehow or other, I have these guys to take care of. These two and those two. Because this now has to point up to there, that has to point down here, that has to point there, and this prev has to point up there. So I'm looking for 4 statements. And the order's going to matter. Because right now, temp pointer is here, and that's all I know. I know new nodes prev, and I know new nodes next. I don't want to lose this disconnect. What's the very first one I need to do? Oh, let's try. If I go to here, I can do that, right? That's just going to get the value of temp pointer. That's good. What would I do second?
New node next equal temp pointer next.
Excellent. It's gonna go there. It's gonna go there. These were both null, so I haven't really lost anything, but I have this guy now connected. Okay? What would be third? I think temp pointer's next. I think this is the one we would do third. And this one down here we would do fourth. Okay. What are those lines of code? New nodes, prev, gets the value of
Temp pointer.
good. Temp pointer. New node next gets the value of new node's next. That's this. It's going to get the value to point here. Which line points here? That bad boy right there, right? I want this to point to this node. Currently, this is what points to that node. And that's temp pointers next. Next up, I want to take care of this line, which is temp pointers next. Is going to get the value of, what's this guy's address?
New node.
New node, good. And my fourth one was this guy now has to point to new node. Well, what do I mean by this guy? That's this guy right here, right? So it can point backwards. So something else is going to get the value of new node. Which was this right here. What was this address? Well, knowing temp pointer, it's going to be,
Next previous.
yeah, temp pointers next. Temp pointers next points to this address, and at this address, we want to get this address. So it's prev, next prev. Oh, of course, there's going to be more to this, but this bad boy's starting to get long. Trying to do all of that to insert in the middle. What if I wanted to do a quick one here? We're starting to run out of time, which again, I brought that up earlier. 5, 8, 10, and pointer. I want to delete 8. Okay. My apologies. I'm coming through and I want to delete 8 and 10 pointers right here, right now. And it does not equal 5. It doesn't. Temp pointer gets temp pointers next. So now I move it over here. And temp pointer is sitting right there. It's pointing to this node. And I check and the value does equal. Bam. I need to delete this node, destroy it, have 5 point to 10 and 10 point to 5. 2 lines of code. Well, let's see. I said this guy right here and this guy are the 2 big ones. This guy now needs to point to here. This guy now needs to point to there. If I'm drawing the picture, this gets a whole heck of a lot easier. I knew what I wanted to do, but I just drew the picture, and I think I'm almost there by looking at the picture, because this has to become that. This has to become what that was. So let's see, what is this guy right here? Temp pointers,
Previous
previous,
equal temp.
not yet. Temp pointers previous is just this guy, right?
For previous next.
Yes, I need the next in there. Good. That now gets the value of
Temps next.
temp pointers next. Good. Ka-ching, took care of that one. Here's the other one.
Temps next. Previous equals temp previous.
Temp pointers next. Prev, okay. Equals, you said it, I think.
Yeah, temps previous.
Yep, temp pointers previous. Destroy this node. I changed this guy. I changed this guy. Destroy temp pointer. Nice. Nice. Nice, nice baby. Okay. I liked it. I liked it. Now, extra for experts. You want to get good at this stuff? This is what you broke the ice a little bit on this Wednesday. Maybe you want to get together and say, hey, let's work on this Wednesday. It's going to make me a better student. Wednesday at 11, I'm going to jump on. And here's what you could do. I want you to take this old list program. Well, it's actually my list spec file and implementation file, and go in there and add a prev and go through and make it a doubly linked list. Okay. Add a rear pointer, fix insert and delete. I might fix delete because we just saw a big chunk of how we'd fix delete. Have a traverse that starts at the end. You can delete append, but take what you already have and you want to get good at doubly linked lists, meet up with your classmates at 11 on Wednesday and do that. And do that. Okay.